Each chlorine atom has 7 valence electrons. Watch as phosphorus moves to the center and 5 chlorine atoms surround it. Each chlorine shares 1 electron with phosphorus, forming 5 single PCl covalent bonds. As a result, every chlorine atom attains a stable octet. Phosphorus is now surrounded by 10 electrons. Unlike second-period elements, phosphorus can accommodate more than 8 electrons. This is called an expanded octet. According to VSPER theory, 5 bonding electron pairs arrange themselves to minimize repulsion. As the molecule takes shape, phosphorus pentachloride adopts a trigonal bipyramidal geometry. 3 chlorine atoms occupy equatorial positions with 120 degrees bond angles, while 2 occupy axial positions with 90 degrees and 180 degrees angles. Notice that axial PCl bonds experience greater repulsion, making them slightly longer and weaker than equatorial bonds. In the gaseous state, phosphorus pentachloride exists as discrete covalent molecules. However, in the solid state, it forms ionic species, phosphorus tetrachloride, and phosphorus hexachloride. Phosphorus pentachloride is widely used as a chlorinating agent, in organic synthesis, and in the preparation of acid chlorides. To summarize, phosphorus pentachloride is covalent. Phosphorus forms 5 bonds. An expanded octet occurs. The molecule has trigonal bipyramidal geometry. Axial and equatorial bonds differ in position and strength. But one question remains: why can phosphorus expand its octet while nitrogen cannot? Explore electronic structure and periodic trends to discover the answer.